Today we're going to look at angles of rotation and we're going to work a little bit in radians. Have a look at a little bit of terminology to begin with. So if we're looking at an angle of rotation, it's usually formed by starting and end positions of a ray that was rotated around a center point. We've seen this in the unit circle. So in the unit circle, we say that the angle begins here at the initial side here, and then we define an angle as a rotation anti-clockwise until the side reaches a terminal side. And this gives us theta. So this one looks around about 130, 140 degrees that we've rotated in this one. And as we've seen, we can keep rotating round and round. So if the angle rotates just less than one revolution counterclockwise, that's going to give us an angle between 0 and 360 degrees. But we can keep rotating round and round and come back to the same position on the terminal side. So the new vocabulary here is that word here, coterminal angles. So we can say that two angles are coterminal if their terminal side lands in the same place. So obviously all of the coterminal angles to any particular angle would be theta is equal to theta 1 plus n 360 degrees. So if we rotate it by 360 degrees, we can get any coterminal angles. Give an example of this one. Let's find out what angle is coterminal with 130 degrees. So 130 degrees plus one lot of 360 would give us the angle 490 degrees. So we can say that 490 degrees is coterminal with 130. If we wanted a negative coterminal angle, we could take 130 and we could have n equal to -1. So we can take one lot of 360 degrees away. And if we take 130 minus 360, it's going to give us the negative angle of 230 degrees. So this is a possible coterminal angle to 130 degrees, which is negative. Now, let me see. I just want to introduce some vocabulary there. Little review, unit circle. So we've seen the unit circle, looks a little bit like that. How many degrees are there in a half rotation? So if the initial side is here, and we want the terminal side to be over here, giving us one half rotation, that's going to be 180 degrees. If we do that in radians, it's going to be pi radians. And this quotient is really important to us because it's what lets us convert between degrees and radians. So if we want to know how many degrees 3 radians is, or how many degrees a half a pi radians are, or pi over 2 radians, we have this conversion factor here of any value to find the angle in degrees, you take the angle in radians, you multiply it by 180 over pi. If you want to go the other way, if theta is in degrees already, then you multiply it by pi over 180. This little ratio is easy to remember. It's what we get here. One way to remember which way up it is, because I always struggle, is it pi over 180 or is it 180 over pi? And to remember, think about the units. This unit in degrees has to cancel this unit in degrees there. And then you know which way up it needs to be. That's how I remember. What is a radian? One radian is such that, so if you imagine, if we keep moving the terminal side, we can keep rotating it around. The radius is going to stay the same. So we rotate it around until the point where the arc length here, S, is equal to the same length as the radius. So one radian, it's about 57 degrees. One radian is when the radius of a circle sector as drawn here has the same length as the arc. And that's how we define what a radian is going to be. Everything starts working really well from that point onwards. There are 2 pi radians in a whole circle. There's pi radians in half a circle. One radian is around about 57. Now, let's work that one out. So what is 1 radian? We want to use the formula. How many degrees is equal to 1? Well, that means we need to times it by 180 over pi. Just pull up my calculator on that one. We want 180 divided by pi, 57.29. So that is going to give us 57.3 degrees. Okay, so let me just play with this a little bit. If we have the formula here, let me just make this a little bit bigger. If we have this formula, theta in degrees is equal to theta in radians times by 180 over pi. If we're looking at the arc length of a circle, so if this distance here is called the arc length, well, it's always a fraction of a rotation. So if the circumference of a circle is equal to 2 pi r, and we have theta in degrees here, we want to know how long this section is there. So let's say, for instance, give an example, let's say theta in degrees is equal to 100 degrees. How long would the arc length be if this is r? So the circumference of a sector, so the arc length S is going to be 100 over 360 degrees multiplied by 2 pi r, because it's a percentage. It's going to be 100 over 1/60th of a whole rotation. So we just multiply it by this little percentage conversion. So if that distance in degrees is multiplied by 2 pi r, this is going to give us the arc length. However, theta in degrees over 360 is going to give us the arc length for any particular circle. It's not a useful formula, but if I go back to the previous page and I take this formula here, let's take this formula here. Theta in degrees is theta in radians times 180 over pi. Let's watch what happens there on that one. So that's going to give me theta in degrees, which is theta in radians, times by 180 over pi. 180 over pi. This is all over 360. And then that's times by the circumference of the circle, 2 pi r. Let me simplify that for you. We've got theta in radians times by 180 over 360 times by pi, that's our fraction, times by 2 pi r. So pi here cancels with pi here. 180 times 2 is 360, so that cancels here. So the circumference of the length of an arc, if theta is in radians, is simply theta times r. And that gives us this formula here, which is an easy formula to use for finding the length of an arc. Okay, convert each measure from degrees to radians or radians to degrees. So we need to convert 20 into radians. So you've got to multiply it. You've got 20 degrees. Remember, it's either going to be this as your conversion factor, or it's going to be this. I can never remember which one is which. I just know that half a circle is pi, and half a circle is 180. So this is the ratio. Never remember which is the right one. I've got to get rid of the degree symbol, so I have to have the degree symbol in the bottom. So it's this way up. So I can simplify that one. That's going to give me pi over 9. Let's try the next. So just using the formula then, we've got 315 times by pi over 180. On your calculator, what you want to do is you're going to leave the pi in. So you just move this across, 315 over 180 pi. And then 315 divided by 180. If it doesn't give you as a fraction, press menu 2 7 pi over 4. So this is 7 pi over 4. So 600 over 180 pi. 600 divided by 180. If you want to make it always come in fractions, escape, control, nope, think. Document 7.2. I'm in flow format. I've got approximate. I'll switch to auto, calculation mode, and exact arithmetic on. It should give me straight off 10 pi over 3. 10 pi over 3. Minus 60. So that's going to be minus 60 over 180 pi. Do this one in my head. Those 2 cancel. That's minus pi over 3. Convert to degrees. I've got to add so I've got pi over 8. The pi has to get cancelled by something, and I have to add a degree symbol to the whole process. So it goes the other way up. These 2 cancel like this one, and this is equal to 180 over 8. 180 divided by 8. 45 over 2, so 22.5, I don't want exact now. 4 pi over 3, so we've got 4 pi over 3, we're going to multiply by 180 over pi, so on the calculator, I'm going to do 4 times 180 over 3, 240 degrees, and so on. All right, some solving equations now. We need to solve this equation. I'm going to do it without a calculator. So let's rearrange the equation to sine theta is equal to a half. We need our exact value table for this one. So let's pull up the exact value table. 0, 30, 45, 60, 90. That is going to be the sine values, cosine values, tangent values, 0, a half, 1 over root 2, root 3 over 2, and 1. This is 1. Root 3 over 2, 1 over root 2, a half, 0. This one's going to go 0, 1 over root 3, 1, root 3, undefined, and so on. So pull up your exact value table nice and quickly like that. You've got to memorize these values in math. We need these ones memorizing. But then you can just convert these. So if you remember that 180 degrees is pi, that means 90 is pi over 2. How many lots of 60 are in 180? There's 3 lots of 60. This is pi over 3. How many lots of 45 are in 180? Well, 45, 90, 135, there's 4 of them, 180. So this is pi over 4. And this is half of pi of 60 degrees. So this is pi over 6. This is still 0. Get used to pulling up the radian ones fairly quickly. So what we've got here is, that means that theta is equal to Let me just pull this on. That means theta is equal to this. So we've got two possibilities. P theta is equal to pi over 6 or 180, which, is pi minus pi over 6. Pi is 6 pi over 6, so this is pi over 6, 5 pi over 6. With radians, always work in fractions. You'll get quicker at it and it will get easier. Always work in fractions like this one. Don't forget, pi minus pi over 6 is 6 pi minus pi over 6. In my head, I'm thinking of 6 minus 1 over 6 pi, like that. 5 pi over 6. Okay, let's solve this one. So unit circle it a bit like this. We know from our exact value table, the one that we want is this one here. Cosine is equal to root 3 over 2 when it's pi over 6 again. Where's that going to give us? So here and here, here's pi over 6. And the cosine value is equal to, this is when the cosine of x is equal to root 3 over 2. So we want these ones over here. So you've got to use the symmetry of it. That means this is pi over 6. This is pi over 6 here. This is pi there. So my two angles are that 2 theta is going to be pi minus pi over 6, or theta is equal plus pi over 6 would be that second one. So 2 theta is going to be 5 pi over 6, or 7 pi over 6. Remember that pi is 6 pi over 6. Got to halve that. It's going to give me theta is equal to 5 pi over 12. Just times it on the bottom. 7 pi over 12. Now I've got to find all of the possibilities that are in this interval here. So I've halved these angles, so they're no longer there where they're on the unit circle. So there could be more. So this is always, remember, plus n2 pi. So it's one of these two plus n2 pi. So now it's one of these two plus n2 pi over 2 divided by 2 plus n pi. So this is going to give me 4 answers. I've got 5 pi over 12, 7 pi over 12. Now I'm going to add 12 pi over 12 each time to get each one. So 15 plus 12, 17 pi over 12. 7 plus 12, it is 19 pi over 12. And this will get me all of the solutions. All right, my last problem for today. Sorry, I'm going through this fairly quickly. I've only got 20 minutes at the end of my day making this video for you in case we need it tomorrow. So I'm going very quickly. A point on the sun's equator makes a full revolution once every 25 days. The sun has a radius of 400,000 miles and at its equator, and the angular velocity is given there. Let's have a look at how we're going to do this. Let me think this one through. So what we need to do is, what is the angular velocity? All right, so I don't know the formula for angular velocity. I'm not a physics teacher. Physics is easy. The answer is always given in the question. Look at this. Radians per hour. So we need our angular velocity. I seem to remember angular velocity is omega. This is measured in radians per hour. So hour is time, radians per time. I'm going to do it as there's the formula. So it revolves, one revolution is 2 pi, once every 25 days. So 2 pi, this is the angular velocity in radians per day. So that's in radians per day. I can't have an equal sign there. That's in radians per day. So 2 pi, I have to divide that by 24 hours in a day. So I've got 25.38 divided by 24 times it like that. This is radians per hour. So pop that onto my calculator. Where's my calculator? 2 pi 25.38 days times 24 hours. 0.0104. 0.010. Sorry, 103 radians per hour. So in 1 hour, it's the angle it rotates is going to be 0.0103 radians. That's how long it goes in 1 hour. So how far does it travel in 1 hour? Well, we need to use the distance it's going to travel in 1 hour is going to be the arc length, which is s, which is theta times the radius. So it travels this much of a rotation times by, sorry, number that was big. There is the radius times by 432,200. Pop that onto my calculator. I'll use the exact value from the previous part, times it by 432,200. It's going to travel at about 4,460 miles. 4,460 miles. So what distance around the sun's axis does a point travel in 1 hour? Well, 4,460 miles. So for this type of question, use the units to help you come up with the formula, and then put your bits and pieces in. All right, our last part for today is some IXLs. I'm just going to do a couple of them for you. So look what we've got here. So the radius of a circle is 1. What is the length of an arc that's a 10 with an angle of, okay, so that would be pi. In that question again. So we've still got a radius of 1. So what would be the length of the arc? That's going to be 35 pi over 18. Okay, you get the idea for that one. Which of the following shows 3 pi over 2 radians in standard position? So remember that this is, so look at the pen. Always remember that, is it going to let me draw on this or not? Okay, well, I'll just draw a diagram like this. The thing to remember in the unit circle is 1 half rotation is pi. So this is half a pi, pi over 2. So this is a half pi. This is 2 half pies. This is 3 half pies. This is 4 half pies. So this one here would be where the terminal angle is showing 3 pi over 2. Which of the following shows 90 degrees? That one's straight up, isn't it? Which one shows 360? We come around back to the start. Might make it slightly harder. Which of the following shows minus 225? So what's my pen? So 180 going backwards bring to here, so 225 is about there. This is minus 225. That one seems to match. Okay, last one. Find the measure of a negative angle coterminal with 30. These ones are easy. You basically take this angle, and we want it to be coterminal, but rotations of 360 degrees bring us back to the starting point. So 30 minus 360 is minus 330. Minus 330. Find a measure, negative measure, angle coterminal with 10, minus 350. We go up a couple, see if that makes it harder. To the 80s. Ooh, that looks like too much work. Find the measure of an angle coterminal. Find the measure of a positive angle coterminal with minus 210. So remember, coterminal angles are separated by rotations of 360 degrees. So minus 210 can be brought around by adding 360 to it. That will bring us to 150. All right. Have I done all of these? Did I do one of those? Oh, no. Convert between radians and degrees. How many is 90 degrees? Pi over 2. 45, pi over 4. Sorry. So I'm not really showing any method here. I've just memorized this after years of work on those ones. The way I'm thinking about these is generally with the standard angles, the pi over 3, pi over 6, 30, 60, 45, I'm thinking about the unit circle. Thinking about this being pi and this being 180. This is half of it, pi over 2, plus there's 2 of those. There's 4 of these, 60 degrees, there's 3 of these, and then fractions of 30, there's 6 of these. So I've got 30 is pi over 6, memorized. I've got 45 is pi over 4, memorized. 60, there's 3 60s in 180, pi over 3. 90, there's 2 90s in 180, pi over 2. There's 6 30s, there's 4 45s. I remember how many multiples of these will take me to 180. That's basically what I have memorized. And that gets me those angles. When it gets more complicated like this one you can actually see it, it's not too hard. But if you just want to use the simplest way of doing it, you've got 270. So this one pen. You've got 270 degrees. I'm going to make the degree symbol disappear, so pi comes on the top, the 180 goes on the bottom. So 270 over 180. That's 3 over 2 pi, I think. Is it 3 nines, 2 nines. Yeah, 3 nines, 2 nines, 3 over 2, 5. 3, 5 over 2. Submit. All right, that's it. Good luck on that one.